Hello everyone, welcome back to your favorite and India's most affordable learning platform, Physics Wallah. So in the last session of work energy power, so we discussed the basics, what is the work done and what is the work done by the constant force and what is the work done by the variable force, and then we have also discussed so how to find the work done so if the force versus displacement graph is given, and we have solved some questions as well in the previous sessions, right? So today work energy power, the lecture number 2 we are going to start. So in the lecture number 2, so we'll focus mostly on conservative and non-conservative forces, and if possible we'll start the work energy theorem. Otherwise I'll start the what is kinetic energy and some questions related to kinetic energy we'll discuss. So after discussing about the energy, so then we'll relate work and energy. So the theorem which is related to work and energy is called the work energy theorem. So you have the basic idea of that in your class 9th itself, right? Chalo. So first our major focus is on the conservative and non-conservative forces part. Okay, so chalo, so let's start the session without wasting much time. So I just need your attention for the next 1 hour, guys. So avoid all the disturbances around you, and at the end of the lecture it's very important to prepare your own short notes. That's very important. Chalo, with very high positive energy, let's start the today's lecture. So firstly, what is conservative force and what is the work done by a conservative force and work done by a non-conservative force. So the work done by conservative, the work done by or against a conservative force, it does not depend on the path. It just depends on the initial and final position. See, if the force is conservative, let's suppose, so if the force is conservative, so the work done by that force will not depend on the path. Okay, so let me tell you through simple example. So here, let's suppose, so A to B some work has to be done. Okay, so we applied some force. Okay, so if this force is conservative, so I did the work in the path 1 and in the path 2 and in the through path 3, right? So first we did the work in path 1, so then path 2, in path 3. So if the force is the conservative, whatever the force we used to do the work, if it is conservative, so the work done will be same in all the paths. So the work done in the path 1 is equals to work done in the path 2 is equals to work done in the path 3. So it just depends on the initial and final position. It will not depend on the path. So this force is called conservative force, and work done by that conservative force will not depend on the path. Clear, guys? And work done by or against a conservative force in a round trip is 0, because it just depends on the initial and final position. So the work done by round trip is going to be 0. The work done by round trip is going to be 0. Clear, guys? I'll explain through the example so that you'll understand easier way. Okay, chalo. So this is about the conservative force. So the work done by a conservative force just depends on the initial and final position. It will not depend on the path, and the work done in the work done by a conservative force in the round trip is 0. So you just remember that. So in our syllabus we deal with the gravitational force, spring force and electrostatic force. So the gravitational force will come in the chapter gravitation. So the next we are going to start the gravitation chapter. After 2 chapters we'll start that. And the spring force, we already discussed about the spring force in NLM, and again we'll discuss it in SHM, so simple harmonic motion, and we discussed also in Newton laws of motion, right? And electrostatic force, so where we'll discuss it in class 12th, electrostatics part. So first and second chapters of class 12th, electric charges and fields, and the electrostatic potential and capacitance. So these 2 chapters commonly called electrostatics. There we'll come to know about the electrostatic force. Okay, and these are the 3 conservative forces in our syllabus. What are they? So gravitational force, spring force and electrostatic force. These are the conservative forces. Clear, guys? Understood? Chalo. So let's move further. So now let's discuss one simple example. So work done by a gravity when mass m is moved from A to C. So here is a block of mass m. It is moved from A to C. So but I am taking different paths. So first along ABC, let it be, so along is ABC from here to here and then here to here. So then along ADC, so this is the work done in path 2, and along AC directly from here to here. So let it be the work done in path 3. So let's calculate and see whether we are getting the work done by gravity same or not. So in the path 1 we should get the same, path 2 and path 3 we should get the same, right? So chalo. So first along ABC, just observe the concept. So along ABC. So along ABC means first we have to lift this from A to B, then from B to C. So see here. So this is a block of mass M. So here is a point A. So then it has to be lifted to point B. So what is the height? So to height H. From B to so C point. So what is the length distance? L. So if you observe, first in this case, so the work done by gravity we are finding. So the gravitational force that acts downward always, mg acts downward. So the work done from A to B, the work done from A to B is equals to, so force is downward, displacement is upward. Force is downward, displacement is upward. That's why, shall I say mg into, so the displacement is h into cos 180, shall I write? So that, so it's going to be minus mgh, because cos 180 is minus 1, right? So from here to here the work done is minus mgh, and from here to here, see, so when the object moved to this point, so the mg force will act this side and the displacement will act this side. So the force and displacement are perpendicular to each other. Here the force and displacement are perpendicular to each other, right? So that, shall I say the work done in the BC is going to be 0. The work done along the BC is going to be 0 simply. Yes or no? So that, so therefore the total work done along the ABC path will be equals to work done in AB plus work done in BC, from A to B and then from B to C. So that's the work done along the ABC path, right? So which is equals to minus mgh plus 0. So which is total minus mgh. So the total work done is minus mgh. Hope this part is clear, guys. Chalo. So now let's find it along the another path. So let's take along which path we will take? ADC will take. Let's take along ADC. So now see here, along ADC means, so from A point is here first. So let's see like this. So A point is here. So here is a mass M, and from first it is moved to point D. The object is first moved to point D. So then from there it is moved to point C. So here is object moved to point C. So mass M and mass M. So this distance is L and this so this height is H. Yes. So this part is clear, guys. Chalo. So now, so first the work done along the ADC will be equals to the work done along AD plus the work done along DC. From here to here the work done, and from here to here the work done. So now see here, first let's find what is the work done along AD. So from A to D, so work done by which force we are finding? The work done by the gravitational force, gravity, right? So the gravitational force will act mg this side. So force is this side and displacement is this side. So shall I say the work done along AD is 0 directly? Yes or no? So whereas work done along DC, you see, so here mg downward and displacement upward. Yes or no? So the work done along DC will be equals to, so the force mg downward and then the displacement h upward, right? So as they both are opposite, the angle between them is 180, right? So that we get again minus mgh. So now the total work done along ADC is equals to, so I can write work done along AD plus work done along DC. So which is nothing but, so this is 0 plus mgh. So this is 0 and this is plus mgh, means plus into minus, minus it will be, right? So the whole work done will be minus mgh. Yes. So that means we got the work done along ABC is minus mgh, and we got the work done along the path to ADC is also mgh, minus mgh. So same we got. So let's check AC as well. Let's check from A to C. See here. So the mass M is here, right? So then A to, this is the point C. So the mass has to be moved to this point, C point. So so this is A, this is array. So let it be mass M. So this is the C point, this is the A point. Chalo, fine. So now the simple understanding here it is, I can say that, so the force is acting this side, the gravitational force is acting this side, and the displacement is this side. So the body has displacement, let it be some height h, or let the some displacement s. So yes or no? So what is the angle between the force and displacement here? So if I draw a horizontal line here, so let this angle be theta, so this is going to be 90. So I can say that the work done along AC will be equals to, so the force mg into the displacement s into, so cos of, shall I say 90 plus theta, cos of 90 plus theta. So this part is clear, guys. Chalo, now so I can write mgs into, so what is cos of 90 plus theta? Second quadrant. In the second quadrant, cos is going to be negative, so which becomes minus sin theta. So this is going to be minus sin theta. So here mg minus, let's write minus in the starting, minus mgs into sin theta. So now let me do some mathematics part here. So in place of let this angle we consider it as theta, right? So now from this triangle, from triangle ADC, which triangle? From triangle ADC, so I am taking the sin theta is equals to, so h by L. So the sin theta is equals to h by L. So I am writing the same here. So minus mg into so or else okay, so h is equals to, or else this is s we considered, right? So h, sin theta is not h by L, sorry, my bad. So sin theta is equals to opposite by hypotenuse. So sin theta is equals to h by s, right? This distance we considered as s, right? From here to here, A to C we considered as s. So that's why opposite by hypotenuse, h by s. So now in place of sin theta, I am substituting h by s. So s gets cancelled. So this is going to be minus mgh. So the work done along AC is also minus mgh. So from here what we can say, guys, here, so what we can say, see here, let me change one more color, let me add one color. Chalo. So from here what we can say, so the work done along ABC is equals to the work done along ADC is equals to the work done along AC. All these three work dones are going to be same, yes or no? So that means as the gravitational force is a conservative force, so the work done is not depending on the path. So in whatever the path you did the work, so that's going to be same. So which is minus mgh in all the three paths. Hope you guys understood what is the work done by a conservative force now, right? Clear? So and if you want to find what is the work done along the loop, let's suppose the work done in this round trip will be 0, I can say. The work done in the round trip will be 0. So if they ask in the question, if they ask, so along ABCDA, so what is the work done along ABCDA, which is the closed loop, right? So the work done along the closed loop, if the initial and final points are same, so the work done against the conservative force is going to be 0. Clear? Hope the concept is clear, guys. Chalo. So let's move further. So let's take one simple question. So what's the question says? So what's the question says? See here. An object is displaced from 2, 3 to 4, 6 in under a force of 3x square I cap plus 2y j cap. Find the work done by this force if it is given that the force is conservative. See, so the force applied is a position dependent force. That means the variable force, right? So in the last class we discussed, so how to find the work done if the force is the position dependent. So how do we calculate? From x1 to x2 fx dx, y1 to y2 fy dy, and then z1 to z2 fz dz. Fz dz, right? So now see here, so here the work done from here, this is x1 y1, this is x2 y2, so it is changing only in the x and y. So let's take out the z part. So I can write here the integration in x1 to x2, 2 to 4. So what is the force done in the x direction? 3x square dx plus, so integration y1 to y2. So y1 to y2, what is y1 to y2? 3 to 6. So then Fy, what is the force? 2y dy, right? So just do this calculation. So 3 will come out. So then x to the power, here it is 2x. 2x from where to where? 2 to 4, right? So plus, so here 2 will come out. So this is y to the power 1. So y integration is going to be integration, right? Sorry, my bad, guys. So 3 into here it's going to be x cube by 3. Yes or no? So it's going to be x cube by 3 from where to where? 2 to 4. So plus, so 2 common. So here y square by 2. So from where to where? 3 to 6. So you can take out this 3 common, cancel. So you can take out this 2 common, constant, which you can take out. So from here, so I can write the work done will be equals to x cube. So which is 4 cube minus 2 cube. So plus, so here it is 6 square minus 3 square. Yes or no? 6 square upper limit minus lower limit. So then this is going to be 1664. So this is 8. So this is 36 minus 9. So that we get this is 56 plus. So this is going to be 27. Yes, chal. So next, so we got 70 plus 13, 83 joules. So the final answer is 83 joules. Option 4 is the correct one, guys. Clear? Understood, everyone? Chal. So let's move further. So now, what is the non-conservative force? Opposite to the conservative force. What's that? So the work done by a non-conservative force, it depends on the path. So the work done by the non-conservative force, it depends on the path, and the work done in the round trip is not zero. So here in this particular case, the work done in the path 1 is not equals to the work done in path 2. So it not equals to the work done in path 3. So here the work done by a non-conservative force depends on the path, whereas the work done by a conservative force will not depend on the path. Clear, guys? And then, so the major, what are the non-conservative forces in our syllabus? So one is frictional force and the other one is air drag. We do not use this. So the friction force is a non-conservative force, remember. The frictional force is a non-conservative force. The work done by the frictional force in the round trip is not equals to 0. We'll see questions as well so that you'll understand better. So chalo, so let's solve this question so that all the doubts related to the conservative and non-conservative forces will be cleared. Okay, chalo. So a body of mass √2 kg is taken up an inclined plane of length 10 meters. So the coefficient of friction between body and inclined plane is 0.5. So the work done by the gravitational force in upward and downward journey. So the gravitational force in upward and downward journey. See here. So first thing is, so let me go for the concept, the first question. So what we have to find? The gravitational force in upward, the gravitational force in upward and downward journey. First let's find in upward journey. So what does it mean by upward journey? So that means the object is moving upward, the object is displacing upward, so its weight mg acts downward, right? So that, so what is the component of mg this side, it which comes mg sin 45, yes or no? So the gravitational force component mg sin 45 is this side. So the work done by the gravitational force, in the upward journey, work done by gravitational force in the upward journey, I am writing it as. So what is the force that is acting? mg sine 45. The force that is acting is mg sine 45 into, so what is the displacement? What is the displacement, guys? So the displacement is, let it be some s into, so shall I say, as the both are in opposite direction, so this is going to be cos 180 degrees here I can write, right? So here mass is √2 kg, and then g, let it be, so and then sine 45 1 by √2, and then s, so it is displaced 10 meters of s, so it is displaced by 10 meters into cos 180 minus 1. So here √2 cancel, 10 into 10 100, so minus 1, so which is minus 100 joules. So this is the work done by the gravitational force in the upward direction, so upward journey, that means body is moving upward, the gravitational force is downward. So now let's see the second part. So the work done by the gravitational force in downward journey. So let's see in downward journey, in the downward journey. See here, so in the downward journey what happens? So first thing is, in the second case the object is moving downward, so that means its displacement is downward and the force is also downward. So the work done by gravity in downward direction will be equals to, so mg sine 45 is the force, and then the displacement s is also downward, the displacement s is also downward into, so the cos 0 I am writing because the downward journey and the gravitational force is also downward. Downward means along the inclined plane, and what is the gravitational force component along the inclined plane? Mg sine 45, right? So here I can write m is √2, g is 10, sine 45 is 1 by √2, so s is 10, cos 0 is 1, √2 cancel, 10 into 10 100 joules. So the work done in the downward journey by the gravitational force is 100, whereas upward journey minus 100 joules. So the first question is done. Now, so what is the work done over a round trip? So what is the work done by the gravitational force over a round trip? So round trip means, so upward journey plus downward journey. So here I can write, so the second question. So let me do the second question here. So the work done by the gravity in round trip, so will be equals to, so in the upward journey it is minus 100 and in the downward journey it is plus 100. So 0 we got, same by calculations, as the gravitational force is a conservative force, so the work done by gravity in the round trip is 0, as write down as gravitational force, as the gravitational force is conservative, as the gravitational force is conservative, so the work done by gravitational force, the work done by gravitational force in round trip is 0, in round trip is 0. Hope the concept is clear, guys. Now, alright, done. Chalo. So this is the first and second question, so this is also done, right? Chalo. So the next one, what is the frictional force in upward and downward journey? So let's go for the next slide. So let's go for the third one, the frictional force in upward journey first. The frictional force in upward journey. Upward journey. See here, upward journey means the object is moving upward. The object is moving upward. So here, if the object is displacing upward, and then, so the frictional force will act downward. So what is the frictional force? So that frictional force is, shall I say, mu n cos theta, right? So mu n cos theta, right? So which is nothing but mu n, n means mg I can write. So the cos 45 degrees will come this side. So that means the displacement is that side and the mu mg cos theta is this side. So that's why the work done by the friction in the upward journey is, so what is the frictional force that is acting? Mu mg cos 45. Mu mg cos 45 is the upward, frictional force into, what is the displacement? Yes, into, So they both are opposite direction. So that's why cos 180 degrees. So here mu is 0.5, which I am writing it as 1 by 2. So m is root 2, g is 10, and cos 45 is 1 by root 2. So displacement is 10. So cos 180 is minus 1. Root 2 cancel. 2 ones are, 2 5s are. So here we left 10 into 5 minus 50, right? So minus 50 joules is the work done by the frictional in upward journey. Now, so let's go for, so the frictional force in downward journey. The work done by the frictional force in downward journey. In downward journey. So now understand carefully here, guys. See, if the object is displacing downward, so the friction will act upward. The friction always opposes the relative motion. Yes or no? So if the displacement is downward, so the friction will be upward. If the displacement is upward, the friction will be downward. Yes or no? So here the friction will act, mu mg cos 45 will act in this direction. So now the work done by the frictional force in the downward journey, the work done by the frictional force in the downward journey will be equals to, so the mu mg cos 45. So this force is acting, frictional force is acting now upwards, and the body's displacement is downward, s, and as they both are opposite to each other, so I can write cos 180 degrees there, right? So which is nothing but mu is 1 by 2, m is root 2, g 10, cos 45 1 by root 2, s 10, cos 180 minus 1, right? So root 2 cancel. So 2 ones are, 2 5s are. So 10 into 5 minus here 50. Here minus is there. So that's why minus 50 joules. So that means the work done by the frictional force in upward journey is minus 50 joules, and work done by the frictional force in downward journey is also minus 50 joules. So here the friction acts always, the friction always opposes the relative motion of the body. So that part you should remember, guys. Done? Clear? Chalo. So and next question. So the third part is done. So then they are asking what is the frictional force over a round trip. See here. Now this is important. So now the fourth question. The frictional force over round trip. Over round trip. So that means in the upward journey plus downward journey. So the work done by the friction in the round trip will be equals to the work done by the friction in upward journey minus 50 plus the work done by the friction in downward journey, which is minus 50. So which is minus minus, so here minus 100 joules. So which is not equals to 0. As the frictional force is a non-conservative force, so the work done by the friction in the round trip is not 0, guys. Understanding? So but whereas the gravitational force is a conservative force, so the work done by the gravitational force in the round trip is 0. But in the friction, it's not 0. Clear now? So what is conservative and what is non-conservative forces? Understood, everyone? Hope the concept is clear now. Chalo. So let's move further. So we don't need another slide. So let's delete these two. Chalo. So now, how to check if the given force is the conservative or not? So let's suppose if the force is given as a function of the displacement fx I cap, fy j cap, and fz k cap. So if the force is given, so in 3 dimensions, okay, so then check whether the given force is conservative or not. So how do we check? Yes, we have formula for this. Don't be afraid of just seeing the formula. So just understand the concept here. So dou fx by dou y is equals to dou fy by dou x, and then so dou fy by dou z is equals to dou fz by dou y, and then so dou fx by dou z is equals to dou fz by dou x. So if these conditions are satisfied, so then if all three are satisfied, So then the given force is a conservative force. So then the given force is a conservative force. Don't worry or don't be afraid by seeing this. So that this is a dou means partial differentiation, which is nothing but you can do the differentiation, that's it. So I'll tell the example so that you'll understand better. So these are the three conditions. So differentiation of x with respect to y is equals to differentiation of y with respect to x. So remember that way. And differentiation of y with respect to z is equals to differentiation of z with respect to y. So differentiation of x with respect to z is equals to differentiation of z with respect to x. That's it. Okay. Chalo. So I'll tell the examples so that you'll understand better. So check the given forces are conservative or non-conservative. So how do we check? So this is a force given. So how do we check this is a conservative or not? So let's see. First thing. So the first dou fx by dou y is equals to dou fy by dou x. Check whether this condition is getting satisfied or not. Dou by dou y, what is the force in the x direction? The x direction force is x is equals to, so dou by dou x of, so what is the fy? Y, right? So dou x by dou y, the differentiation of x with respect to y is 0 and differentiation of y with respect to x is 0, because with respect to x, y is the constant. With respect to y, x is a constant. So here the first condition, both we got 0, 0. So this condition satisfied. All three has to be satisfied. So then the second, what is that? Dou fy by dou z is equals to dou fz by dou y. So that means dou by dou z of y. What is y? Fy, force in the y direction is y. So which is equals to dou by dou y of, what is fz? Fz is, there is no z term, k term is not there at 0. So the differentiation of z with respect, differentiation of y with respect to z is 0 and differentiation of 0 is 0. So the second condition also satisfied. So let's come to the third condition. What is that? Dou fx by dou z is equals to dou fz by dou x, right? So differentiation of x, the force, what is the x? X. So dou by dou x of force in the z direction 0, right? So dou by dou z, the differentiation of x with respect to z is 0, the differentiation of 0 is 0. So that means all three conditions satisfied. So that's why this given force is a conservative force. So I can say the given force is a conservative force. That's it. This is how you have to check. Okay, understanding guys? Chalo. So same you can do this for this also. So xi cap plus xyj cap. So these both are not same. See here. So first let me check dou by dou y of dou x by dou y is equals to dou fx by dou y is equals to dou fy by dou x, right? So dou by dou y of fx, what is fx? X is equals to dou by dou x of fy, what is force y? Xy, right? So differentiation of x with respect to y is 0, and then here, so y is a constant which comes out, y is a constant, and dou by dou x of x is going to be 1, right? 0 is equals to y into 1. So that means here 0 is not equals to y. So 0, left side we are getting 0, right side we are getting y, which means these both are not equal. So shall we say that this given force is a non-conservative force now? This given force is a non-conservative force. So no need to check the other conditions. So if all three satisfies, so conservative force. If any one of them has failed, so it's a non-conservative force. That's it. Understood? So check other questions as well. So here, first let's check the first condition. What's that? Dou fx by dou y is equals to dou fy by dou x. So dou by dou y of fx, what is the force in the x direction? Xy. And then so dou by dou x of, so what is fy? Fy is yx, alright? Chalo. So now see here, So with respect to y we are differentiating, so x is a constant, take it out, and then dou y by dou y is 1. So which is equals to here, with respect to x you are differentiating, y is a constant, take it out, and then dou x by dou x is 1. So therefore here x is equals to y, x is not equals to y, so therefore this is a non-conservative force. This is the first condition itself has failed, so that's why it's a non-conservative force. Yes or no? So we did correct only, right? X, y, so differentiation of fine, correct. So now f y I cap x j cap. So again do the same thing. So the first condition, so the dou fx by dou y is equals to dou fy by dou x, right? Dou by dou y of fx, what is fx? Y, and then dou by dou x of fy. So what is fy? The force in the y direction is x. So dou y by dou y 1, dou x by dou x 1. So the first condition satisfied. So you have to go for the second one. So what's the second condition? So the dou fy by dou z is equals to dou fz by dou y, right? So here what is the dou by dou z of fy? So fy is x, right? Dou by dou y, dou by dou y here. So dou by dou y of fz, force in the z direction is 0, right? So that's why dou by dou z of x is 0 and dou by dou y of y 0 is 0. So the second condition also satisfied. So now let's go for the third condition. So dou fx by dou z is equals to dou fz by dou x. So dou by dou z of, in place of x, what is the force in the x direction? Y. So dou by dou x of the force in the z direction is 0. So it is constant 0. So this is also 0. All three conditions satisfied. So this force is a conservative force. The given force is a conservative force. Clear, guys? Hope the concept is clear. Understood, everyone? Chalo. So let's move further. So can you guys take this as a homework? So the force is given. So first check, see, find the work done by the force along the path closed path, along the closed path OBCAO. OBCAO. So first check whether the force is given conservative or not. So how do we check? So let me solve. So the force is equals to y I cap plus x j cap. So first condition, the dou fx by dou y is equals to dou fy by dou x. So here dou by dou y of fx is y and dou by dou x of fy is x. So differentiation of y with respect to y is 1, differentiation of x with respect to x is 1. The first condition satisfied. So let's go for the second condition. So the dou fy by dou z is equals to dou fz by dou y. So dou by dou z of fy, what is fy? X. Dou by dou y of what is fz? 0. So differentiation of x with respect to z is 0, differentiation of 0 is 0. So let's go for the third condition. Dou fx by dou z is equals to dou fz by dou x. So here dou by dou z of fx, what is fx? Y, which is equals to dou by dou x of fz 0. So differentiation of z with differentiation of y with respect to z is 0 and this is also 0. All three conditions are satisfied. So the given force is a conservative force. So therefore the given force is conservative force, right? The given force is conservative. So if the force is conservative, so shall we say that what they are asking? So the work done in the closed path. So the work done in the closed path is going to be, or else write that path. What is that path? So the work done along OBCAO is going to be 0 because the work done by a conservative force in the round trip is 0. Simple concept. Clear, guys? Understood? Sure. So now let's move for the next concept, that is the kinetic energy. See, you already know the formula for the kinetic energy. What is that? Half mv square, right? So if the object is there, so this object has some mass m. So if it is in motion, if any body which is in motion, it will possess the kinetic energy, right? So or the energy which is possessed by the body by the virtue of its motion is called the kinetic energy, right? So now, so if it has some velocity v, so then the kinetic energy of the body will be equals to half mv square, right? So that is, I wrote the formula here. And one more thing, the kinetic energy is a frame dependent. So how it is frame dependent? So let me tell you. Let's suppose you and your friend are traveling in a bus. So you and your friend are just sitting adjacent to each other, and then so one of your another friend, so he is standing outside. So the bus is moving. Okay. So or else let me tell in this way. So here is a person A, and here is a person B. So and here is a person C. So person A and person B are in bus. So it is moving with velocity v. So and person C is outside. Sorry, person C is outside. So now shall I say, with respect to person C, person A is in motion, person B is in motion. So that means person A has velocity v, person B has velocity v with respect to the person C. So whereas if the person A and B with respect to each other, they are in rest. With respect to person A, person B is in rest. They are sitting in the bus, right? So with respect to person B, person A is in the rest. So that means the same two persons are in motion with respect to the person outside, but with respect to each other, they are in rest. So we can say, from here we can say that the kinetic energy is path dependent. Yes, sir, not path dependent, frame dependent. So the kinetic energy is frame dependent. Yes or no? Understanding, guys? Sure. So next, so let's see some questions based on this. What's this question says? See here. A ball of mass 2 kg and another mass of 4 kg are dropped together from a 60 feet tall building after a fall of 30 feet each towards earth. So their respective kinetic energies will be in the ratio of, see here. So here the first thing is, so this is a 60 feet tall building, and here also let's take the 60 feet tall building. So this is 60 feet tall building, and this is also 60 feet tall building. So now here the 2 kg body is dropped from here, and then here also 2 kg body is dropped. So 2 kg or 4 kg? So it is 4 kg, sorry. It is 4 kg body is dropped. So now after a fall of 30 feet, so after a fall, let's suppose it has fallen 30 feet. So after 30 feet, let its velocity be v. So and then after 30 feet, so let its velocity be v dash. So find its velocity. So its initial velocity is 0 because the body is dropped. So dropped means initial velocity is 0. So and its acceleration will be equals to minus g, and then so the height is equals to 30 feet, and then so the final velocity v, let it be. So I can say v square minus u square is equals to 2as. So from here I can write, so u square is 0, however, so the final velocity is 2 into a is minus g and s is minus 30, you can write. So which is nothing but v is equals to root over 2g into 30. So here we got. So same thing here. So the v dash square minus u square is equals to 2as. So here the v dash square is equal minus 0. So this is also dropped, initial velocity 0. So 2 into a is minus g. So s is minus 30, I am writing. Why minus 30, sir? Because the final position is below the initial position. The displacement has to be taken negative, right? We already discussed it in the motion as straight line, right? The motion under gravity. So here v dash whole square is equals to 2g into 30. So the here v dash is equals to square root of 2g into 30. So that means these two bodies have the same velocity. These two bodies have the same velocity. So now the ratio of their kinetic energies, the kinetic energy of 1 to the kinetic energy of 2. So the first body's kinetic energy is half into its mass is m1 and its velocity is v square by half into, so the second body's kinetic energy will be its mass is m2, so and its velocity is v dash square. So here v dash and v are same, so they gets cancelled. Half gets cancelled. m1 is 2, m2 is 4. So 2 by 4, which is 1 by 2. So that means, so the kinetic energy ratio is 1:2. Option 3 is the correct one, guys. Understood? Clear? So let's see the next question. So what's the question says? See here. So a particle is projected making an angle 45 degrees with horizontal, having kinetic energy k. So here a particle is projected, so let's suppose with some velocity u, so with respect to the horizontal it's making an angle 45 degrees, let's say. So with the horizontal having kinetic energy k, so the kinetic energy at the highest point will be, so it makes a projectile path like this. So at the highest path, at the highest point, so it will have the initial horizontal component of velocity is u cos 45, right? So here it has the kinetic energy k. So the kinetic energy initial k is equals to half mu square. Its velocity is u, right? So now at this point, at the highest point, so it will possess only the u cos 45 degrees. U cos 45 degrees. Let the kinetic energy be k dash here. So the kinetic energy at the highest point k dash is half into, so its mass will not change, mass is same, but its velocity is only u cos 45. The only velocity is u cos 45 whole square, because the vertical component of velocity will become 0 at the highest point of the projectile path. We have seen that. So u, here u square, and here cos 45 whole square means 1 by root 2 whole square we can write, right? So this is in place of half mu square, shall I write k into, so this is 1 by root 2 whole square is 1 by 2, so which is k by 2. So that means the k dash is k by 2. So the kinetic energy at the highest point is half of the initial kinetic energy, because the vertical component of velocity will become 0, only horizontal component will exist. But initially there is a horizontal component as well as vertical component. Understood, guys? Simple questions, right? Chalo. So let's take one more question. So what's the question says? If the vehicle speed is increased by 1 meter per second, its kinetic energy is doubled. So find the then original speed of the vehicle is. So first let original speed be v. Let original speed be v. So if the original speed is v, so initial kinetic energy, let it be half mv square. So now if speed increased by 1 meter per second, if speed increased by 1 meter per second, so then its velocity will become, so the v dash will be equals to v plus 1 meter per second. Let the new velocity be v dash, which is equals to v plus 1. So then the kinetic energy final will be half, its mass will not change. So in place of v dash I can write v plus 1 whole square. So now what they are saying, its kinetic energy is doubled. So that means the k final is 2 times the k initial. So the k final is 2 times the k initial. So which we can write half into k final is what? M into v plus 1 whole square is equals to 2 times. So what is k initial? Half into mv square, right? So here half gets cancelled, m gets cancelled. So here v plus 1 whole square is v square plus 2v plus 1, right? Yes or no? So here this is going to be 2v square. So bring everything to one side, so which will become v square minus 2v minus 1 is equals to 0. Yes or no? V square, if I send it to that side, it will become v square minus 2v minus 1 is equals to 0. Yes, correct, only right? Half into m into v plus 1 whole square is equals to 2 into, so its kinetic energy is doubled. So 2 times the initial is half mv square. Half cancel, cancel, v plus 1 whole square is equals to 2v square. Yes, fine. So now let's do it by the quadratic formula. So let's write here v square minus 2v minus 1 is equals to 0. So a is equals to 1, b is equals to minus 2, c is equals to minus 1. So I am using the quadratic formula. So the v is equals to minus b plus or minus b square minus 4ac by 2a. So what is minus b? Minus of minus 2 plus or minus square root of b square minus 2 whole square minus 4ac. 4 into a into c is minus 1 by 2 into a is 1. So this is minus of minus plus 2 plus or minus, so this is 4 plus 4 by 2. So which is nothing but 2 plus or minus root 8 by 2. So which I can write here. So v is equals to, so 2 plus or minus, so I can write 4 into 2, so 4 comes out. So 2 root 2 by 2. So v is equals to either 2 plus 2 root 2 by 2, or V is equals to 2 minus 2 root 2 by 2. So here if I take 2 common, so 1 plus root 2 by 2. So 2 cancel, it should be 1 plus root 2 meter per second. So the initial velocity, or V is equals to, if I take 2 common, 1 minus root 2 by 2. So this is 2 cancel, which is 1 minus root 2. So root 2 value is greater than 1, so the velocity can't be negative. So ignore this part. So this should be the answer, root 2 plus 1 or 1 plus root 2. So root 2 plus 1 or 1 plus root 2. Option A is the correct answer, guys. Clear? Understood the concept, everyone? Chalo. So that's it. So just we discussed till the kinetic energy. So in the next session, we'll start the work, energy, power concept. So till then, keep studying. All the very best, guys. Bye. Take care.